Assalamu alaikum students. In today's video, we are doing questions, CAIE questions on kinematics and dynamics. You know that the kinematics is a branch of physics in which we study about the motion of the body without discussing the forces involved. But in dynamics, the forces which are involved which cause the motion of the body are also discussed. So today's video consists of the questions which are regarding both kinematics and dynamics. Okay, most of the questions are from section B of the old pattern of the CIE paper 5054. And since the concept, of course, is always the same, and the questions which I have chosen, they have the graphs in them, they have the use of Newton's second law of motion, etc. So let us start our video with our questions which I have chosen for today's class. I have started with the easier questions. Okay, and the questions are starting from 2006 to 2020. Okay, so let us start our topic, the discussion, today's discussion. The first question is regarding the motion of the cyclist who starts from rest. He accelerates and then travels at a constant speed. At 12 seconds, a cyclist applies the brakes and slows down. Photographs are taken of the cyclist at 4-second interval. Figure shows the result. So at 0 second, t equals to 0 second, he starts from rest. And in 4 seconds, he has covered 8-meter distance, according to the figure which is shown here. And then after 8 seconds, he has covered more distance than before, that is 22 meters, because one small division here represents 2 meters. So 22 meters. And then in next 4 seconds, he has covered from 22 to 36. Means up till here he is accelerating and then he's going at the constant speed. Whatever is the speed at 8 seconds, the same is the speed at 12. And then the brakes are applied at 12 seconds. And of course, when the brakes are applied, he will slow down. Okay, so on the graph below, draw a possible position of the front wheel of the cycle at 16 seconds, and B on figure below plot a graph. So at t equals to 16 second, where he could be, because he has applied the brake, so it means he will be slowing down. He will not be covering that much distance as he was covering before, because in the previous 4 seconds he covered 2, 4, 6, 8, 10, 12, 14 meters. In the previous 4 seconds again he covered 14 meters. But of course in the next 4 seconds, that is from 12 seconds to 16 seconds, he should cover less distance than before. Okay, so his distance should be less than 50, because when I mark at 50 means he has covered the same distance, but he is slowing down means that the distance should be any position less than 50 meters. So where should I mark? I will mark anywhere here in this position. This could be possible. Say this one means 44. You could do 46, 48, any position before 50. Now you have to plot the graph for the various position of the cyclist. So the first position he has covered in 4 seconds is 8. So where will I mark? On the graph, I will mark at 4 seconds. At 4 seconds, he has covered 8 meters. Means 8, this is 10, this is 20, and this is 30. So in 4 seconds, he has covered 8. Means this would be the position. Then in 8 seconds, what is the position of the cyclist? Uh, his position is, I will check the graph, I will check the question. He has covered 22 and then 36. 2, 4, 6, 36. So the positions are marked and I have plotted the graph already. I have just shown one position, 8, 10 and 8, 22 and 36 will be the position. So let me show you the graph. This is the graph which is to be plotted. In 4 seconds, he has covered 8 meters and in 8 seconds, 22 and then in 12, 36, then he's slowing down. So any position you could have marked. Here I have marked 44. Okay, so he is slowing down. So how will you calculate the average speed? The marking scheme is also included in this. So you can see any position before 50, the position where will he be at t equals to 16 second. Then the points which are to be marked correctly, only plus minus half a square mistake is allowed, not more than that. From origin to 4-second curve drawn, and it is increasing gradient. I will show the graph again. This is increasing gradient, means he is accelerating. Then this part shows from 8 to 12 constant speed, and then it is decreasing gradient because the distance time graph. So straight line portion, that is from 8 to 12, shows the straight line portion, means the constant speed, and this is increasing gradient. 4 to 8, increasing gradient, then constant speed, and then decreasing gradient. So distance time graph, when the gradient is decreasing, means body is decelerating. So the last part shows the deceleration. So you have to calculate the average speed during the first 12 seconds. What will you do? In first 12 seconds, the total distance covered is 36 meters and divided by 12. So 36 divided by 12 will be, let us solve it, 3 meter per second. 36 in 12. That is 3 meter per second. Let us have a look at the marking scheme. Yes. Okay. So all the points are plotted, and first part shows the increasing gradient, then uniform speed, and then decreasing gradient. Next question is from 5054, variant 21, May June 2020. This is related to thinking and braking distance. The figure shows thinking distance and the braking distance for a car being driven along a dry road and along a wet road at the same speed. Okay, thinking distance is what? When the driver is going at certain speed and he sees the hazards and applies the brake. So the distance covered during that time, between time interval taken by the driver to see the hazard and applying the brake, that is reaction time. So distance covered during the reaction time is thinking distance. So on dry road it is 18 meters, and the braking distance on dry road is 43 meters. Okay, what is braking distance? The distance covered after the brakes are applied. If you want to show the graph on this, what will be the shape of the graph for this case? You will draw a straight line, whatever is the speed of the driver, that will be a straight line. Then he applies the brake. If the deceleration is uniform, then he will come to rest. Depending on how long does he take, this is y-axis speed and x-axis time, v and t. So this is the speed with which the driver was traveling, and reaction time usually for a healthy person is 0.6 to 0.7 second. And the brakes are applied later on, and the body decelerates. So if he decelerates uniformly, this will be the uniform, that is a straight line going towards the time axis where the speed becomes 0. So braking distance is this area under this part of the graph. And this is the thinking distance, which is from 0 to 0.6 second. 6 second, 0.7 second for a healthy person. So this was the shape of the graph which I just shown. That is not needed in this question. So what is asked? That is, calculate the total stopping distance for the car on the wet road. It means you will add the thinking distance. Stopping distance is what? Sum of thinking distance and braking distance. So 60 plus 18, that is 78. So what will come here? What will you write? That is 78. Unit is important. Meter is the distance which is covered. Complete the sentence. The thinking distance is the distance traveled between seeing a hazard and applying the brake. What will come here in this blank? Applying the brake. The brake. Suggest why the thinking distance is same on in both the roads, on both the roads, because thinking distance depends upon initial speed with which car was traveling and thinking time. So thinking time does not change on wet road or dry road. That remains the same. And initial speed with which the car was traveling, if the initial speed with which car was traveling is same on both the roads, means the thinking distance will not be different. It will remain the same on both the roads. Explain why the braking distance is larger when the road is wet. Of course, road is slippery. Tires have less grip on the ground, and there is less opposing force on the tires. So the car travels greater distance on wet road and smaller distance on dry road. The marking scheme is attached here. 78 meter, the starting to applying the brake, time taken to think and react. Okay, that is reaction time, distance covered during the reaction time. Friction on the wet road is lower, So less backward force, less resistance. So the tires, the car tire slides and they don't have proper grip. Okay. So when that is why the car takes longer to stop. So one mark for telling that the friction is less. Okay. And another mark for what? The distance covered is longer. So that car will decelerate less or less acceleration. That is negative acceleration. The third question is also related to speed, that is speed time graph, and this is also about the thinking and braking distance, something like that. At t equals to 15 seconds, the brakes are applied. Car is traveling. The speed is not mentioned. You have to note down the speed. You have to tell the speed. So here, one small division is equal to zero point 0.5. So state the speed of the car just before the brakes are applied. So you have to read it from here. And what is that speed? That is this one, 10, 11.5 meter per second. Let us go to the next part of the question. Explain what is meant by uniform deceleration. Okay. Uniform deceleration means the distance which the decrease in uniform speed is uniform with respect to time. Decrease in speed is constant with respect to time. A lorry travels at a constant speed of 18 meter per second for 15 seconds. So this is another body which is traveling. Car was traveling at 11.5. The lorry is traveling at 18 meter per second. So at time t equals to 15 seconds, the brakes are applied and the lorry slows down with the same deceleration as the car. So on the figure, you have to draw the speed time graph for the lorry. So what will you do? You have to choose 18. Where will 18 come on the graph? It will be somewhere here, 15, 16, 17. This is 18. Means this will be the line which will be drawn here. And at the same time, the brakes are applied, means here at t equals to 15. That means, and the car decelerates at the same rate. So my line is curvy, but this has to be a straight line. Okay. So I will take the picture from here. Okay. So initially the lorry is traveling at 18. So 18 will come here. 15, 16, 17, 18. And the brakes are applied at the same time, that is t equals to 15. Then it will decelerate at the same rate. Means this will be the shape. It means the slope of the graph has to be same. So it's taking longer. When the initial speed is greater, the car will take or body will take longer time to come to rest, even if the deceleration is same. So distance covered also by the lorry will be more than the distance covered by the car, because distance is area under the graph. For the car, this is the distance. You will calculate area under the trapezium because it is the shape of trapezium, or you can take what? The rectangle plus triangle. You can have two parts, rectangle and triangle. So find the area under the rectangle and area under the triangle, and add them. The lorry's distance will be greater because area under the graph is greater. What is meant by uniform deceleration? We have just defined it. A lorry travels at a constant speed for 15 seconds and the brakes are applied and slows down as the same deceleration. This is also done. So we have drawn the graph as well. Explain how your graph shows that while braking, the lorry travels greater distance further than the car. You can see it again. You can check this area under this triangle. Second triangle is greater than the triangle here. So this is the second triangle and this is this distance which I'm just marking, this one. So then, of course, this is bigger triangle. So area under the triangle is greater. It shows that the lorry travels greater distance while braking. Now next question, 5054 21 variant and May June 2011. This is marking scheme actually. Mm, of the previous question. That is 11.5, where we just discussed decrease in speed, that is negative gradient, equal changes or decrease in speed in the same time. What is meant by uniform deceleration? Okay, so one thing, the speed decreases. 1 mark will be awarded for writing the negative gradient or decrease in speed. And the next mark will be awarded for what? That is equal change in speed, equal decrease in speed at the same time interval. Okay. Now part B is also done. That is the graph was plotted. So flat line at 18 meter per second, 1 mark, and constant slope, second mark. So this is also of 2 marks. Greater area under the graph, that is only of 1 mark. Now question number 4, and that is from May June 2011, 5054. So figure shows a skydiver who is falling vertically. The skydiver starts from rest at time t equals to 0. His acceleration is non-uniform until he reaches a steady speed of 50 meter per second at t equals to 10 seconds. He opens his parachute at t equals to 20 and decelerates until t equals to 25 seconds. From t equals to 25 seconds, he falls at the steady speed of 5 meter per second. On the graph, that is figure 9.2, because this is question number 9 of that year, draw the speed time graph for a skydiver. So here the graph is to be plotted, and for first and second, he goes with non-uniform acceleration until he reaches the constant speed. It means the graph will not be a straight line. Okay. So if I start from 0, so up to t equals to 50 seconds, in 10 seconds, the graph will not be a straight line. Means it will be curved. If I draw a straight line that is up to 50 seconds, this will be wrong. This should have decreasing gradient. Okay, so instead of drawing this way, what should I do? I should take that is the gradient is decreasing in the beginning, the gradient is more, and then he reaches 50 meter per second, and then he goes at that speed for further 10 seconds. And the graph is plotted here. You can see the graph which is plotted. So in 10 seconds, he goes with non-uniform acceleration and reaches the speed of 50. This is 50 here. And then he continues traveling at this speed from 10 to 20 seconds. That means for further 10 seconds. He goes at that speed. And then the parachutes are opened. When parachutes are opened, that means the upward force will be greater than the downward force. Means at this time, at this point, what will happen? This is the parachutist, and upward force will be larger than the weight. This is W. So resultant force act in upward direction. What will be the resultant? R minus W. Okay, I should label something else to this. Suppose this is drag force. So our resultant will be D minus W. Means he will be decelerating. Or this is upward acceleration because the acceleration is always in the direction of resultant force. So resultant force is upwards. Okay, because the drag air resistance is greater than the weight. So D minus W. So the parachutist decelerates, and then he opens the um, parachute. After he slows down, why does he reach the speed of 25 meter per second, 5 meter per second in 25 seconds? Because what happens at t equals to 25 seconds, the speed of the parachute is also air resistance also decreases with the speed. Since speed decreases, why speed decreases? Because there is an upward acceleration or deceleration. It means he slows down, so air resistance also decreases with the speed, and eventually it reaches 5 meter per second, and the parachutist lands with that speed. Let us go to the next part of the question. So the graph is plotted. I've shown the graph. State how your graph shows that the acceleration is non-uniform because the gradient is decreasing. Have a look at the graph. In the beginning, the gradient, it's a straight line, means uniform acceleration, then decreasing acceleration. It's not deceleration. This region shows the decreasing acceleration, means the speed is still increasing but at lower rate. Explain in detail why after a skydiver opens his parachute, he decelerates and eventually reaches a steady speed. When he opens the parachute, of course, I just showed the resistance becomes more than the weight, so resultant force acts in upward direction. And he comes to due to decrease in speed, the air resistance also decreases. And the lower value of terminal velocity, that was 50 meter per second, was the upper value of the terminal velocity, which was without opening the parachute. And 5 meter per second is after the parachute is opened. As the speed, as he opens parachute, happens? I am writing D, upward force becomes greater than W. He decelerates Due to decrease in speed, what happens? Air resistance also decreases. The greater the speed, the greater will be the air resistance in the opposite direction. Due to decrease in speed, D, that is air resistance, decreases. And he attains the lower steady speed. What will happen? Let us have a look at this. Explain in detail why after skydiver opens his parachute, he decelerates and eventually reaches a steady speed. So this I just wrote the answer. For the time interval between t equals to 10 seconds and t equals to 20 seconds, calculate the distance that the skydiver travels. So t equals to 10 seconds and 20 seconds. So that is a uniform speed. So what will we do? We will calculate the area under the graph. So this is 10 and this is 20. So 20, the 10 into 50, that is 500 meters. So what will be the answer here? That is 10 area under the graph into 50. He was traveling at 50 meter per second and the time is 10. So that is 500 meters. So answer is 500 meters. The mass of the skydiver is 60 kilogram. For the time interval between t equals to 20 and t equals to 25 seconds, calculate the average deceleration. So the time interval is 5 seconds. And what was the initial speed? 50. So 50 minus 5 delta V, A equals to delta V over delta T. So 50 over minus 5 divided by 5 because 25 minus 20, that is 45 over 5 means 9 meter per second square. So this is average deceleration. Then average resultant force. How will we calculate average resultant force? F is equal to ma. Mass of the skydiver 60 into 9 means 540 Newton. State how your graph in figure 9.2 may be used to obtain the distance that the skydiver falls. So what will you do? From you will calculate area under the graph. I will just show you the uh, the marking scheme of this part. So curve with this is the marking scheme of this part. So we have already plotted and I have shown this. and gradient is not constant. That is the answer of that part, in which it was asked why the gradient acceleration is non-uniform. Graph curves, not a straight line. So this only of 1 mark. But the first part, plotting graph, is of 4 marks. Okay, curve with decreasing gradient from 50 meter per second at 10 seconds. From origin to 50 meter per second. 1 mark for this, constant speed, 1 mark for from 10 to 20 seconds, then decreasing speed from 25 from to 50 to 5 meter per second at 25, and then constant speed until he goes until at least t equals to 30. That means for further 5 seconds. Okay, and gradient is not uniform. This is also done. Mention this answer I wrote. Any that air resistance, drag force upward larger becomes greater than the weight, so resultant force acts upwards. Okay, and due to decrease in speed, air resistance also decreases, and eventually uh, goes with the lower value of the terminal velocity. This also was calculated, 9 meter per second square. All the parts were done. Okay, now the next question, the speed time graph for a racing car of total mass 650 kg as it sets off from the rest at the start of the race. So this is year 2011, October, November, and variant 22. So this is the graph starting from rest and reaching the speed of about 72 or 74. Let me check it. If I take it this way, this is 72. One small square is 2 meter per second. So the speed is 72 meter per second. Calculate the distance traveled between t equals to 0 to 9 seconds. What will you do? This is 9 seconds. That is here. Area under the graph. What is the formula of area under the graph? Half into, because this is a triangle, base into height. Half base 9, height 72. So this is 36, and 36 into 9, 324 meters. Distance traveled, acceleration of the car, the final speed 72, initial speed 0, 72 divided by 9 means 8. Mm. 72, this is not to be done here. Minus 0 divided by 9, delta V over delta T. 8 meter per second square. So what is the force? F is equal to ma. So acceleration 8. 650, I guess, was the mass. I don't exactly remember. Anyhow, I'm writing this. So when you multiply, you will get the force acting. So that will be in Newton. The acceleration of the car is constant at equals to 0 and 9. Suggest and explain why driving force on the car must increase to keep the acceleration constant. Because when the car speeds up, air resistance also increases. Okay, so if the driving force is same, air resistance may cause it to have decrease in speed. Okay, and the car may go at a constant speed later on instead of accelerating. In order to keep the car accelerating, the driving force should also increase. Hmm. Air resistance. One mark will be for this. Since car is accelerating, it means speed is increasing. Air resistance increases with speed. So what will happen as a result? The car may go at a constant speed instead of accelerating. So it means driving force should increase to keep the car accelerating. Decrease in acceleration. Okay. After 9 seconds, the car starts to turn a corner and follows a circular path at a constant speed. Explain why the car is accelerating. Because when body moves in a circle, the direction changes at every position. Okay. In circular path, the direction is different at every point, even if the speed is constant. Means the car is, whenever there is a change, and velocity is what? Change in either speed or change in direction. And when there is a change in velocity, the body is accelerating. So velocity is not constant, but speed is constant, because velocity may change due to either change in speed or direction. So direction is changing here. Okay, direction changes. So speed is constant, but not the velocity. The marking scheme, 72 meter per second, area under the graph. Okay, so the error is allowed, little error is allowed. So 322, 324 meters. Okay, so you have to calculate 1 mark for all this calculation and 1 mark for the right answer with unit. Change in velocity. So 8 meter per second square as was calculated. 650 was the mass into 8. So answer is 5.2 into 3 newtons. Okay, so here you have to keep number of significant figures same as that of the raw data. Raw data has two significant figures in mass value and two significant figure in acceleration value. So raw data, this answer also has the same number of significant figures. So now the friction or resistance increases as the speed increases. Okay, so that the uh, forward force should increase, so that the resultant force, unbalanced force, should keep on acting in the same direction. Okay, so 3 marks. So there should be the 3 points. The direction of the car is changing. Okay, I think I skipped any of the part of the question. Okay. This part. At 9 seconds, car starts to turn a corner, follow the circular path. Why the car is accelerating even though the speed is constant? Because the resultant force is acting in the towards the center. Okay, resultant force is acting towards the center. That is the centripetal force. Now, the question number 7, that is 5054, variant 21, May June 2015. Here, this is a satellite which is orbiting the Earth. The diagram is not to scale, means you can't calculate the diameter or radius of the track of the satellite. The satellite travels at a constant speed in the circular orbit Underline the quantities in the list below that are scalars. Acceleration, force, mass, speed, and velocity. Force, mass, and speed are scalar quantities. Rest of them are vectors. The velocity of the satellite changes, but its speed is constant. So, what is meant by velocity? Velocity, rate of change of displacement. That is, change in displacement with respect to time. Explain why the velocity changes. As we discussed in the previous question, the direction changes. Even if the speed is constant, direction at every moment changes. 1 mark for this. Explain what makes this satellite move in an orbit that is circular. So gravitational force of Earth provides necessary centripetal force. Uh, I am writing CPF for centripetal force. Okay, so it means the 1 mark will be for the gravity, which provides a centripetal force, and of course, a body needs a centripetal force acting on it to move in a circular path, so that is provided by the gravitational force. The satellite is placed into the orbit by the rocket. And figure 9.2, of course, this must be question number 9 in that, and this is the second figure, shows a rocket as it takes off. Okay, so the rocket and the fuel have the total mass 40,000 kilogram and a total weight 400,000 Newton. So this is because the old paper, so the value of G was taken as 10 meter per second square. But according to new requirement, value of G is 9.8 meter per second square, until unless you are instructed to take G equals to 10. You have to take G equals to 9.8 meter per second square according to that. Okay, the resultant force is acting in upward direction, and that is 50,000 Newton. Weight is 400,000 Newton. So calculate the thrust. So thrust, what will we do here? What is the force? That is thrust is weight is 400,000 Newton, and the resultant force is 50. Is equals to W goes to the side, R plus W. R plus W means R plus W mean W is this is 50,000 plus weight 400,000. So what will come? 4 Newton. So calculate the acceleration. Acceleration will be what? The resultant force A is equals to F over M. F is 50,000 divided by mass is 40,000. So answer will be 1.25 meter per second square unit must. So we have calculated the acceleration as well. In the first 4 minutes after takeoff, the acceleration of the rocket is uniform. State what is meant by uniform acceleration. First thing, acceleration means it's increase in speed, and then increase in speed with respect to time is constant. Okay, same increase in speed for same time interval. So here you have to sketch the graph. 0 to 4 uniform acceleration, 4 to 6 increasing acceleration, 6 to 10 decreasing acceleration, and then 10 to 12 constant speed. So the graph is already plotted here for you. Uniform speed, uniform acceleration, sorry, up to 4 seconds. Then increasing acceleration means the gradient is increasing. Then decreasing acceleration, it is not deceleration. It is decreasing acceleration. Then constant speed from 10 to 12. So this was to be plotted on this. State how the speed time graph is can be used to find the distance, that is area under the graph. So here the answers are shown. The all were calculated for you earlier. Answer of acceleration 1.25 meter per second square. Same change in speed in the same time. Now the question number 8, 5054, 22 variant, October November 2014. What is meant by uniform acceleration? Same answers as above. Same change in speed. Okay, this thing you may write. Acceleration is a vector quantity. How a vector quantity differs from a scalar quantity, you all know it. That is, the scalar quantity doesn't need direction. Okay, only magnitude is sufficient, but vector quantity needs direction to be mentioned. A rock from the space is traveling in a straight line at a height, uh, high speed when it enters the Earth's atmosphere. Figure 9.1 in the speed is the speed time graph for a rock from t equals to 0 to t equals to 50. Okay. So t equals to 0, what was the speed? 12,000 meter per second. And then it decelerates non-uniformly. Okay. But there is a region where the deceleration is uniform also. Okay. And then at certain speed, 2000, it comes to rest in 40 seconds. So, and this figure 9.1 mark where the rock is moving at a constant speed. So, which region will be marked? The region here between 20 to 30. Okay, this is the constant speed, and you have to give letter X to this, Y to where the uniform deceleration, constant speed, sorry, this one, up one, and this is uniform deceleration, Y and non-uniform deceleration. So, what will we do? This is mm, so this is X, constant speed, Y, uniform deceleration. This region here too, here you can say non-uniform deceleration, Z here. This is also non-uniform. Any of them can be marked. Okay, so these two regions are non-uniform, and one region is that is 12,000 meter per second was the constant speed. At t equals to 25 seconds, the mass of the rock is 8 point. Mass is changing means. Okay, at this time, the rock's mass is 8.4 kilogram. And for the time t equals to 25 seconds, determine the size of acceleration of the rock. Now here it is very important. What? You don't have to take the time exactly at this 25. The region where the acceleration is uniform is to be marked. So you can take this. Let me take it to this part. Uh, Now, this part which is where the acceleration is uniform, that is this region. We will take the easier one, and t equals to 20. The graph is a straight line. This part is uniform. This one. Okay. So, what is the speed at this time? So, what is one small division equal to? There are five divisions are 2000. So, what is one small division equal to? There are five divisions. Let me check. One, two, three, four, five. Yes, five division 2000. So, what is one division divided by five? That is 400. So, 8,000, 8,400, 8,800, then 8,800 plus 400, 9,200, 8,400, 8,800, 9,200, 9,600. Okay. And this one, the lower one, 4,400. So time interval 10. So 9,000 delta V over delta T. A equals to 9,600 minus 4,400 divided by 10. The answer is coming 520 meter per second square. Okay, so 520 meter per second square is the acceleration, or that is negative acceleration or deceleration of the rock. The resultant force acting, F is equal to ma. 8.4 is the mass into 520. That is equal to 4368 Newton. So we have calculated resultant force on the figure. You have to, at t equals to 25 seconds. What is that? The rock is traveling towards the earth, and you have to draw and label two arrows to show the direction of the gravitational force and air resistance, direction of travel. Air resistance will be acting in the opposite direction to that of the direction of travel. So where will we do the air that is mm, uh, the air resistance will be exactly opposite to it. We have to label it R, and the gravitational force F. That will be mm, perpendicular to the surface of the earth. So this will be F. Just why the size of the air resistance changes as the rock travels through the atmosphere. Of course, when it travels through the atmosphere, the density of the air will be greater in this, and due to the increase and speed, gravity increases, the gravitational pull increases, the speed increases, and due to increase in speed, air resistance also increases. So any of the answers you may write here, because it's only of 1 mark. Suggest what happens to the rock at t equals to 40. At t equals to 40, what will happen to the rock? It may stop. It may hit the surface of the earth. Let's see the marking scheme. Changing speed or velocity, and that is the acceleration, uniform acceleration. The answer, the vector quantity has the direction. All these we have marked, x, y, and z, two values. Okay, so that is to be calculated. 500 meter per second square. We were getting 520, so that is okay. And then our answer was also in 4,000 something. Okay. Now arrows we have labeled. It hits the ground, stops, speed becomes 0. Now next question number 9. Figure 9.1 shows a larger container ship traveling at constant speed in a straight line. Okay, so resistive force is acting, and that is 2.8 into 10 to the power 6 Newton. And the speed is 9.7 meter per second. Calculate the work done against the resistive force in 1 second. What will be the distance traveled in 1 second? You know the formula, distance is equal to speed into time. V into T. So 9.7 into 1. That is 9.7. So this is the distance traveled. So work done is equal to force into distance. So 2.8 into 10 raised to the power 6 into 9.7. 2.8 exponent 6 into 9.7. So what is coming? 2, 7, 1, 6, and 4 zeros. Joule. Okay, so this has only two significant figures. So what we can write, we can also express our answer in two significant figures. That is 2.7 into 10 raised to the power 1, 2, 3, 4, 5, 6, 7. 10 to the power 7 joule. So number of significant figures, if they are taken care of, that will give good impression to the examiner. And in ATP papers, if the answers are not up to appropriate number of significant figures, the marks are deducted also at some points. In paper 2, you may not be penalized, but it's good to write answer in appropriate number of significant figures. Engines are powered by oil. State the energy changes when it takes place when the ship is traveling at a constant speed. Okay, so it means the chemical energy of the petrol or chemical potential energy of the petrol is providing the energy to the forward force to this like kinetic energy, but what is happening, it's not, the speed is not increasing. It means there is some opposing force acting, that is resistive forces. How much was the resistive force? 2.8 into 10 to the power 6 Newton force was acting on it. It means the work done against the resistive force was appearing in the form of heat. So chemical potential energy of the fuel to the thermal energy, because kinetic energy is not changing, it is constant. The mass of the ship is 2.2 into 10 to the power 8. The engines are switched off and the resistive forces cause ship to decelerate. Calculate the initial deceleration of the ship. So what was the initial resistive force? 2.8 into 10 to the power 6. And F is equal to ma. The mass is given. A is equal to F over m. into 10 raised to the power 6 divided by 2.2 into 10 raised to the power 8. This is 2.8. Okay. So 2.8 exponent 6 divided by 2.2 exponent 8. What is the answer? 0.013 meter per second square. We don't need to put minus sign because it's written deceleration. As the speed of the ship decreases, its deceleration changes. Suggest and explain how the deceleration changes. Of course, when speed decreases, the resistive forces will also decrease. Okay, speed decreases, the deceleration changes as the resistive forces also decrease. Okay, it means the finally what will happen? The resistive forces may become equal to the forward force. Okay, and the resultant force, which was in the backward direction, that was less. In this, you have to sketch the graph for the ship as it decelerates to rest. So in the beginning, what was happening? The deceleration is decreasing. Okay. So it means the shape will be what? It will not be constant deceleration. In the beginning, this will be rapid deceleration, and then later on, it is slow deceleration. Like this. Okay. There will be more decrease in speed because it was decreasing, decelerating. Then deceleration decreases. The rate at which it was slowing down was decreasing. Explain how the distance traveled by the ship may be determined from the speed time graph. So distance is area under the graph. If it is plotted in graph paper, you have to count the squares, okay, centimeter square, and you have to add them up. When the ship is traveling at a different speed, the energy is being supplied to the engines at a rate of 33 megajoule per second. That is the power which is provided. The efficiency is 0.36. That is 36%. State the relationship that defines efficiency. What is efficiency? That is useful output divided by provided input. Useful output divided by input. Calculate the rate at which the energy is wasted. Okay, so it means if 36% is useful, it means 64% is wasted. Okay, so which formula we will use? I will just write here. Efficiency is equal to useful output over input. So what was the energy? 33 megajoules. So either you take 36% and then subtract it from the total energy provided, or you can take the energy wasted also. Okay, so here I am taking 36 the percent or 0.36. Otherwise, I will have to divide it by 100. So instead of doing this, 0.36 is equal to 30. What was the energy which was provided? Mm, this energy is, so the energy which is provided is 33 megajoule. So 33, this is the useful output. So 3.36 into 33, that is giving us 0.36 into 33, 11.8 megajoule. That means almost this is useful. So wasted means out of 33 minus 12. So 33 minus 12 gives us 21 megajoule. Okay, so this is the energy which is wasted. So this is the marking scheme. Work done is calculated. The answer of acceleration, you can see chemical potential to thermal energy. Why don't we write kinetic energy? Because the speed is not changing. Speed is constant. So it means there is no change in kinetic energy. So where is that use in chemical potential energy appearing? That is appearing in the form of heat. Work done against resistive forces appearing in the form of heat. Acceleration, we got the same answer. Okay. So uh, you have to show the decreasing gradient. This was shown as area under the graph. Okay, all these parts were discussed. Okay, 1 mark for writing the formula of efficiency, 1 mark for the substitution of the values, and 1 mark for the right answer with the appropriate unit. Now, this is the last question, and this is 5054, variant 21, October, November 2021. So, here this is the person of mass 80 kilogram and standing in a lift, that is elevator. The gravitational field strength is 10. So, this was of 2021. So, that is why the G is 10. And even if in these papers also, like the paper in which you will be appearing, if it is mentioned to take 10 Newton per kg, you can take it. You will have to take it. Okay. Calculate the weight of the man. So, what was the mass? 80 kg. So, what will be the weight? 800 Newton. Lift accelerates upward at uh, 0.5 meter per second square. Calculate the resultant upward force. So what will you do for the resultant upward force? F is equal to ma. Mass 80 and into 0.5. That is 40 Newton upward. Let us see the next part. The force exerted on the man by the floor of the lift. Okay. If the lift moves at a constant speed, upward force will be equal to downward force. But the lift is accelerating, that is going upwards. And the resultant force is acting in upward direction. What was the resultant? Upwards. And this was 40. And this is the person and the weight 800 Newton. Means upward force has to be greater than the weight. When the lift accelerates upwards, the floor of the lift pushes the person upward with the greater force. So that means it will be 840. So 840 minus 800 is 40, which is the resultant. Okay, so when lift accelerates downward, then the weight will be greater than the contact force. Okay, here contact force is providing the difference between contact force from the floor of the lift on the person and weight provides the resultant of 14 Newton to the elevator. So that is why it is accelerating upwards. When lift accelerates in the downward direction, then the weight will be greater than the contact force. Contact force will be less. That is why when the lift goes down, you feel uh, that you are lighter. When lift is accelerates upwards, you feel that as if you are heavier because contact force is 840 Newton for the person here. Okay, the force exerted on the man by the floor of the lift, that is 840 Newton, that is contact force. When the lift goes accelerates downward, then the 800, that is the weight of the person, will be greater than the contact force. If the same resultant force is acting, means 800 minus 40, that means 760 will be the contact force which will be acting in the upward direction. The lift accelerates upwards uniformly for 4 seconds, then decelerates uniformly to rest in 4 seconds. The distance traveled is 8 meters. Okay, so first it accelerates uniformly, means straight line, and then decelerates uniformly. And this is a distance time graph, not the velocity time graphs. So what will you do in order to sketch this? Uniform acceleration for distance time graph will be curving upward. Means something like this, up to 4 second uniform acceleration like this. Then what was the question? Decelerates uniformly in 4 seconds. Further 4 seconds, he decelerates uniformly. So we will continue from here. That decreasing gradient. That was increasing gradient to show the uniform acceleration, and then decreasing gradient. So this will be the shape of the uh, graph for the lift. Okay, during the acceleration, increasing gradient, and then deceleration, decreasing gradient. So I will show you the marking scheme of this. Okay, so unfortunately, there is no marking scheme attached. Anyhow, I have given you the answers. 840 Newton is the force applied by floor. Okay, that is contact force. 40 Newton was the resultant force, and the graph which was plotted. So that is all for today. So Allah Hafiz. Will now meet in the other video with some other topic, inshallah.